Good evening, my dear students. Today in these sessions, we are going to discuss regarding the orthogonal asymptotes methods. First of all, read the question, a point P of the hyperbola. So in this question, we understood over here, we need to draw the shape of hyperbola is situated at a distance of 35 mm and 50 mm from the pair of asymptotes. The asymptotes are perpendicular to each other. Draw a hyperbola by using orthogonal asymptotes methods. If you observe in this question, a point P. From this point P, we need to draw the shape of hyperbola is situated at a distance of 35 mm and 50 mm. Let us see, I am taking one point. Okay. I am measuring. First I am marking one point somewhere else. Okay. From this point, what I am doing over here, the height is given. The height is how much is given? 35 mm is given. And length how much is given? 50 mm is given. Is it right? Let us see. From this point, what we can say? Point P. What we can say? Point P. From this point P, we need to measure a length of 35 mm. How much length we have to measure? 35 mm. 35 mm nothing but 3.5 centimeter. How much length we have to measure? 3.5 centimeter. Clear? And then this is the point P. Okay. And then length. Length, how much we need to measure over here? We need to measure a length of how much? 50 mm. 50 mm nothing but 5 centimeter. How much would be that here? 5 centimeter. From this point, we need to measure a length of 50 millimeter. Nothing but 5 centimeter. I am representing here. Let us see. The length is how much is given? 50 millimeter. 50 millimeter nothing but 5 centimeter we need to measure. And this height, how much we have to measure? 35 mm. 35 mm nothing but 3.5 centimeter. Let us see. This length, how much we are taking over here? 50 millimeter. And height is how much? 35 mm toward right hand side, 35 mm toward left hand side. 35 nothing but 3.5 centimeter. Okay. After that, we need to join the points. Clear? Right now, we are getting the shape of a rectangle. Clear? Let's see this figure. Rectangle. I am measuring the dimension. I am showing the dimension. The length. How much is that here? 50 millimeter. Clear? 50 millimeter. Meanwhile, show the dimension. Show the arrow. Clear? The length is 50 mm and height is 35 mm. Clear? From this point, clear? Show the arrow. .35 millimeter. Clear? If you observe this figure, each point is making the angle of how much here? 90 degree. Are you agree or not? This line is making the angle of 90 degree and this line is making the angle of 90 degree. Each line is making the angle of how much? 90 degree. So that's what we can say. We can say as orthogonal asymptote methods. Each of the line, they're making the angle of 90 degree. Is it right? That. After that, let's see. Okay. The asymptotes are perpendicular to each other. Perpendicular nothing but each of the line is making the angle of 90 degree. Is called as perpendicular to each other. Okay. Draw a hyperbola by using of orthogonal asymptotes method. From this point, so this point what we can say? We can say as the origin point. It represents as O. Clear? That. From this point, we need to draw from this point. Let us see this point. We need to draw one horizontal line. Okay. No need to measure the length. But I'm telling you here, from this point, just you need to extend the line. Extend the line. From this point also, you need to extend the line. From this point also, you need to just extend the line. From this point also, you need to extend the line. Clear? That. After that, so this point what we can say O. It is visible. Okay, let us see. This point is called as O and this point is called as A. A and this point what we can say here? B. Always remember, this both of the lines should be equal. Okay. So this point what we can say? Point B. I'm using the black pen. This is A and this is B. And this point what we can say? Point C. And this point what we can say? Point D. Clear? You need to erase this all unnecessary lines. Clear dear? And this point is called as point E and this point is called as point F. Clear? So let us see, each of the point is making the angle of how much here? 90 degree. Is it right? If you observe here, each line is making the angle of 90. From this side 90, from this side 90, from this side 90. So that's what we can say. So this method is called as orthogonal asymptotes method. So each of the lines is making the angle of how much? 90 degree. Is it right? Then after that, you need to mark the random point on which line here? From P to D line. Just mark the random point. I'm representing here 1 on the horizontal line. Again mark 2. Again 3. Again 4. Clear? Let us see, the observer is observed from origin. This projection is passes from 0 to 1. If it is the projection of its passes, then this projections will be fall on this vertical wall. Are you agree or not? Yes. Let us see. We are joining the point 0 to 1. This line should be very light. We have to use H pencil. This pencil we have to use H pencil. Just we are joined. The observer observe from origin to one line. The projections will be fall on vertical line. So this point what we can say 1 dash. What we can say here? 1 dash. This is touching to the one line. So what we can say? 1 dash. From this point, you need to draw one horizontal line because what we want? Perpendicular. Is it right? Draw the horizontal line and draw the vertical line. Both line will intersect at this point. So this point is called as P1. What we can say? P1. Again, you need to pass a line from 0 to 2. Clear? Again, the projections will be fall on the vertical line. So what we can say? 2 dash. We need to draw the perpendicular line. Is it right? Draw the horizontal line. Meanwhile, draw the vertical line. Both line will intersect at this point. So this is what we can say P2. Again, you need to pass a point from 0 to 3. Same thing we have to continue up to the 4. Is it right? 0 to 3. Again, the projections will be fall on the vertical line. So this is what we can say 3 dash. Again, draw the perpendicular line. Draw the horizontal line from this point. Draw the horizontal line and draw the vertical line. Both line will be intersect at this point. So this is what we can say P3. Again, join the point from 0 to 4. Clear? 0 to 4. Okay, the projections will be fall on the vertical line. So this is what we can say 4 dash. So draw the horizontal line. Clear? Meanwhile, draw the vertical line. Both line will intersect at this particular point. So this point, what we can say? Orthogonal asymptotes method points or perpendicular lines. So it is represented as the point P4. Clear? Again, that much is completed. Come to this vertical wall. I told you, if any point, if the observer observe to the point, is it right? Like, which one is there? 5 point. Okay? 5. So you can mark here, random point. What we can say? This is 4 dash, again 5 dash, 6 dash and 7 dash. Clear here? That. The observer is observed from origin point. The projection is passed from 0 to 5 dash. Clear? Then. These projections will be fall at this point. So this point, what we can say? 5 point. Always remember, on the horizontal line, unit represent as 1, 2, 3, 4, 5, 6, 7. But on the vertical line, unit represent as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash. Clear? There. Again, the observer is observed from the origin point. The projection will be passed from origin to 6. Clear? So here, draw perpendicular line. Same procedure we have to follow. Draw the vertical line and draw the horizontal line. So this point, what we can say here? P5. Same thing we have to continue for 6. 0 to 6. Clear? The projections fall on the horizontal surface. So this is what we can say 6 point. From this point, draw the perpendicular lines, draw the vertical line. Meanwhile, draw the horizontal line. Clear? Both are intersect at a particular point. So this point is called as P6. Same thing we have to continue for 0 to 7. Again, projections fall on the horizontal surface. So what we can say here? 7. Draw the vertical line. Meanwhile, draw the horizontal line. Clear? So this point, what we can say? We can say as P7. Okay? Then our intention is that we need to draw the projections of a hyperbola. So this means that from the point P, we need to draw the shape of hyperbola. From the point P, we need to draw the shape of hyperbola. Then you need to join with the help of French curve. Is it right? Or you can join by freehand also, like this. 0 to P1, P1 to P2. So I am using the different pen. Okay, you will understand easily. 0 to P1, P1 to P2, P2 to P3, P3 to P4. You need to extend this line in such a way that this line should be parallel to whom dear to the base of the line. Clear? Then same thing we have to continue from P to P5, P6 and P7. Meanwhile, you need to extend this line. Clear? This line should be parallel to vertical lines. Clear? Just now we draw the shape of hyperbola. So this what we can say here? Hyperbola. Clear? For the hyperbola, we have to use HB pencil. Clear? Whom we have to use HB pencil? Remember, for this box O, F, P, C, we have to use HB pencil. Which pencil we have to use? HB pencil. This should be dark. O to F, F to P, P to C, C to O. Clear? And then let us see from F to A. Clear? This line should be very light. So we have to use H pencil. Again from P to D, we have to use H pencil. Which pencil here? H pencil. From P to E, H pencil. Again from C to B, H pencil. Okay, all projection line from 0 to 1, 0 to 2, 0 to 3, 0 to 4, 0 to 5, 0 to 6, 0 to 7, all lines should be H pencil. Which pencil? H pencil. This hyperbola, okay, we have to use HB pencil. Clear? I hope so. No one is having the doubt regarding these sessions. Clear? So in the next session, we are going to discuss regarding the cycloid. If you like my video, please don't forget to subscribe my channel. Thank you, dear.